Determinant of a square matrix 3 by 3. Now in the previous video we have dealt with 2 by 2 matrix, and we have an expression of a11 a22 minus a21 and a12. Now how then do we now go about evaluating determinant of a 3 by 3 matrix? I mean, should we say that it is this minus this, just like in the previous one? But however, what happens to the other terms? What happens to a12? What happens to a23? What happens to a21? What happens to a32? And stuff like that. And this is very important, because when solving determinants, all the terms must be involved. Just as when we solved the determinant of a 2 by 2 matrix, we can see that a11 was involved. Okay, likewise a12 was involved, a21 was involved, and a22 also was involved. Now, to fully know how to evaluate the determinant of a square matrix, we have to know what we call place signs. Okay, so this signs is just an alternating of positive and negative. So we have positive, negative, positive, negative, positive, negative, positive, negative. Okay, and it goes on like that: positive, negative, positive, negative. Now, but what we are more focused about is a 3 by 3 matrix, because this place sign technique, it works for an infinite bandwidth of matrix, of a square matrix. So, but what we are more focused about is the first 3 columns and the first 3 rows. Now, this shows that we can evaluate a 3 by 3 matrix using any of these formats. So I have plus, minus, plus, and just as I have minus, plus, minus, plus, minus, plus. Yeah, it's going to be very interesting. And what thing I love about solving 3 by 3 matrix determinants is that you don't have a direct way of solving it. You can go through any route. So let's take a look again at A. We have A is equals to a11, a12, a13, likewise a21, a22, and a23, and a31, a32, and a33. Now, interestingly, these placeholders can be fixed on them. So we can have plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, the good thing about matrix is that we can evaluate matrix across any length. We can do this across a 3 by 3 matrix row 1. We can evaluate the determinant across row 1. We can evaluate the determinant across row 2. We can evaluate the determinant across row 3. Likewise across column 1, column 2, and column 3. Now, let's assume we want to follow column row 1. All right, let's solve across row 1 and see what we have. Now, we will observe that we are going to be using a lot of ink, this and this. You will see something like that. But then let's begin. The first thing we will see is we begin with the first term of the row, since we are using row 1. Okay, the terms of row 1 are a11 positive, a12 negative, a13 positive. Now, so the determinant of A is expressed as a11 positive. And now the 3 by 3 matrix is now reduced to a minor of a 2 by 2 matrix. So that means we cross a11 horizontally and vertically, and whatever we are left with is what we use to evaluate the minor. So we are left with a22, a23, a32, and A33. Let me explain that again. We are using row 1, and on the first row, the first element is A11. So we cross A11 horizontally, cross it vertically, and the elements we have left will be our minor. So now the elements we have left is A22, A23, A32, A33. Now let's write that. A22, A23, A32, and A33. Now we are done with the first term of A11. We are done with the first term of A11. Now let's move to the next term of A12. Now A12, the place sign on A12 is negative. If the place sign on A12 is negative, definitely we will now go again. We are dealing with A12. Cross the terms horizontally and cross the term vertically. We'll be left with A21, A23, A31, A33. Let's do that again. We are dealing with A12. We cross the term horizontally, cross it again vertically, and we'll be left with A21, A23, A31, and A33. Now, if that becomes our minor, so this will be A21, A23, A31, A33. Now, finally, we want to consider the last term, which is plus A13. Plus A13. Now, this is it here. Plus A13. The place sign is positive. Now, we cross the term horizontally, we cross the term also vertically, and we left with the minor of A21, A22, A31, A32. Let's go over that again. This is the term that we're considering, the last term of row 1, A13. The place sign is positive, and that is what we have here. Now we cross the term horizontally and vertically. We'll have many terms of A21, A22, A31, A32. So we write terms out, and that gives us A21, A22, A31, and A32. And thereafter, this, this, and likewise these are all 2 by 2 matrix. So we can evaluate the determinant of that. So this will be plus A11, plus A11 into A22 minus, A22, A33 minus A23, A32, the leading diagonal, and the other one, let's consider now A12, the leading diagonal of A21, A33 subtracted from the following diagonal of A23, A31 plus A13, plus A13, the leading diagonal of A21, A32 minus A22, and A31. Now, this is how to evaluate the determinant of a 3 by 3 matrix. Oh, it might be confusing. Why are we using row 1? Why can't we use row 2? Why can't we use row 3? Or why can't we even use column 1 or column 2 or column 3, as the case may be? All right, so let's use the same analogy now. As we evaluate for the determinants, let's use row column 2 now. Let's use column 2. So in this case now, A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. And remember our place signs. Positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. And we are using column 2. And the column 2, the terms in column 2 are, let's use A12, 822 and 832, and the place signs on them are negative, positive, negative. Now this is so interesting. All right, so the first term that we have now to evaluate the determinant is A12, and A12 has the place sign of negative, so we'll be using negative A12. Now negative A12, now this is the term negative A12. Horizontally, vertically, we are left with what? 821, 823, 831, 833. Let's try that again. Let's see. A12. Horizontally, vertically, 821, 823, 831, and 833. And with that done, we say this is what? 821. Okay. 821, 823, 831, and 833. Now we are done with the first term of column 2. Now the second term of column 2 is 822, and the place sign is positive. That is, give us plus 822. Now plus 822 there now means that we have 822 here. Okay, we cover it horizontally and vertically. We are left with 811, 813, 831, 833. Let's go over that again. 822 as a term that we're using horizontally, vertically. The terms left are this. So that means the last 4 terms. So we have A11, A13, 831, and okay, 831 and A33. And finally, the last term, which is A32, and we note that the place sign here is negative. So we have negative A32. And for the negative A32, which is this term here, horizontally, vertically, we are left with this, 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 and this. Again, A32, horizontally, vertically, we are left with A11, A13, A21, A23. So we use that as our minor. A11, A13, A21, and A23. And then we simplify this using the minor here. The minor here is a 2 by 2 determinant. So this will be A12 multiplied by A21, A33, which is the leading diagonal. We subtract it now from the following. That's A31, A23, plus A22 as the leading diagonal. So we have the term here. Then we consider the leading diagonal as A11, A33, minus A31, A13, and finally minus A32, and we consider the term A11, A23, minus A21, A13. So just as we have evaluated using column 2, okay, we can also evaluate using column 3 following the same protocol, or column 1. We can also evaluate using row 2 or row 1, or even row 3. Now, enough of all this gibberish. Okay, yes, I can use whether row or column to evaluate my determinant, or whatever the case may be. Let's go into some examples.